on the review. Number 1, this whole section says to use Pythagorean Theorem. Okay, a squared plus b squared equals c squared. Remember, a and b are always next to the right angle. Doesn't matter which one's a or b, but across from the right angle has to be c. Okay, so let's do this. Okay, so we got 7 squared plus x squared equals 25 squared. 7 squared is 49 plus x squared equals 625. So all I did was square them on the first step. Now notice x squared has a 49 on that side. I got to get rid of that 49. Minus 49, minus 49. X squared equals 576. All right. Whoops. Let me try to get my calculator. Let me get my writing board because the screen is whack. All right, here we go. All right, I'm going to turn this into a new document with no saving. All right, cool. So, over here, with 625 minus 49. Okay, and then we're trying to square root that. Now, if this is a whole number, we'll use it. It is. So 24. Cool. Now, you could do the whole factor tree, but if you know what the square root is, you can just write that whole number. That's fine. Okay, so 24. All right, number 2. If you have a rectangle or even a square, you know each side that's across from each other, the opposite sides are the same. So if we just think about this right triangle, we have, again, a squared plus b squared equals c squared. Okay, so 10 squared plus 5 squared equals x squared. So you got 100 plus 25 equals x squared. So we get 125 equals x squared. And then to get rid of that square, we need to do square root on both sides. So that cancels out. Alright, so the square root of 125, let's do that. So we got 5 times 25, and then 25 is 5 times 5. So I'm left with one pair of 5 and one loner 5. So that would be 5 square root 5. Alright. Down here on number 3, we got 5 and 12. Those are both legs because they're next to the right angle. So we're going to write, again, a squared plus b squared equals c squared. So 5 squared plus 12 squared equals x squared. Now you might remember our Pythagorean triples that we learned. We had 3, 4, 5. We also had 5, 12, 13. This is a Pythagorean triple of 5, 12, 13. But in case you don't memorize that, it is what it is. Let's do the math here. 5 squared is 25. 12 squared is 144. That equals x squared. Add these up, you get 169 equals x squared. And then to get rid of the square, we square root. The square root of 169 is 13. Okay? So, if you were to do this, you'd have 13 and 13. And that's it. Okay? So, number 4, 7, 9, and C. Okay, kind of like number 3, those are both my legs, so 7 squared plus 9 squared equals x squared. So we got 49 plus 81 equals x squared. That leaves us with 130 equals x squared. And then once again, we're going to need to do the square root. Square root of 130, square root of x squared. Okay, and let's do this. 130 is 2 times 65. 65 is 5 times 13. Alright, so again, 2 times 65. Okay, 2 times 65 is 130, 5 times 13, 65. I have no pairs. I need to rewrite this as the square root of 130. Okay? Nada else to do there. Alright, so down here, another Pythagorean Theorem problem. Here's how you know that. You can see we have a right triangle, and you can see that we have two sides we know, one side we don't know. That's definitely going to be a Pythagorean Theorem problem. So let's do it. Let me make sure I got my right. Come here. All right, so we got a squared plus b squared equals c squared. A and b are 5 and h, right? So 5 squared plus h squared equals 10 squared. Now, when we read our problem here, the bottom of the 10-meter ladder is 5 meters from the building. That's all labeled. It's asking us what's the height from the bottom of the building to the top of the ladder. So we are just looking for h. 5 squared is 25 plus h squared equal 10 squared, which is 100. And then we get rid of this 25, minus 25, minus 25. H squared equals 75. And again, last step is to square root 75. So we got 5 times 15. And then 5 times 3. Now, typically, we would actually start that over. And we would do, hold on, it's going to take way too long. Come on. Every time. Alright, so 3 times 25, and then 25 is 5 times 5. We like to use the smallest prime factor first. So, our pair is 5, our loner is 3, right? So h equals 5 squared root of 3. But I want you to know, whenever we're actually looking for a height, an actual meters, an actual like distance, we don't want to leave it as a square root, because in the real world, we don't have square roots on our rulers, and we don't measure with square root numbers, you know. So we need to actually get the square root of 75. So 5 times square root of 3. 8.66, okay. That's what we really needed. The decimal answer, because we're talking about a real world scenario where we have to find a measurement. Okay, kind of like number 6, a pole struck by lightning, broken into 2 pieces. Okay, one piece is still standing 12 feet. So here we got 12 feet right here. And the other part fell at an angle 16 feet away. How tall was the pole before it broke? So before it broke, both of these pieces were connected. So I need to figure out x and then add it back to 12. You might remember this type of problem on the Pythagorean scavenger hunt. We did it with a tree example. This is a pole, but it's the same idea. Okay, so let's do Pythagorean theorem. Whoops. So a and b are 12 and 16. So 12 squared plus 16 squared equals x squared. 12 squared is 144. Okay, 16 squared is 256. Equals x squared. So we're going to add these up. Okay, so we're going to get 400 equals x squared. And then, of course, we have to get rid of the square with the square root. Now, if you don't know the square root of 400, you can type it in the calculator. But the square root of 400 is 20. Okay? 20 times 20 is 400. Now, 20 is not the answer of what it was before it broke. All we did was find out that this is 20. So if I can piece this pole back together, I'm going to have to add 12 and 20. Okay? So 12 plus 20 equals 32 feet. Okay? That's the answer. Oops. Where did my pen go? Don't do that. Oh, don't do that either. Okay, let's try that again. Why do you do this? 32 feet. Cool. Okay, part plus part equals whole. Next. Alright, so we're going to be doing trigonometry. So you remember Sohcahtoa. Okay, typically I write it like this, so it doesn't, as long as you understand what it is. Sohcahtoa. And y'all remember this from yesterday. Right? Y'all remember the Lego Toas and Super Soaking all the Toas? Sohcahtoa, get it? Ha 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 ha. Ah ha ha. It's so funny. Sohcahtoa. Alright, whatever. Back on track. So, sine F. So starting at F. Where's F? Boom. So remember, this tells you where you're starting. So here we go. Let's label O, H, and A. I got my O. Got my H. And my leftover is A. Now all these are F, so this will be easy. You don't have to change OHA. Sine is O over H. So 4 over 5. That's it. Cosine, A over H. Ca, 3 over 5. That's it. Tan, Toa, O over A, 4 over 3. That's it. And that's it. Now, that's just the ratios. Like it says, ratios. Number 16, though, we're actually solving for x. So now we're going to set it up and solve it. So let's do that. We need the right width. So again, from your theta, label OHA. And we cross out the one we don't need. And let's bring this down. Actually, let's just clone that. Sure. Cool. So since we have O and A, we know we're going to use TOA, T for tangent. So let's write that down. Tan, and my theta, my angle is 50, equals, and then TOA, O over A. X is on the bottom, so our little trick is to take the left side and the bottom side and do a little switcheroo, right? So X is going to the left. X equals 17 still on top, and then on the bottom we got tan 50. So 17 divided by tan 50. Okay? So we can go to our calculator and type in 17 divided by tan 50. Now, remember, you need to be in degrees mode. You should be in degrees mode. It should say DEG right here in the top right of your calculator. So we get 14.26. Put that up here, 14.26. Not degrees, units. That's it. All right, over here, starting at the angle, 35. This is my O. Starting at 90, this is my H. This is my A. On this one, I don't need A. So OH is so. So I'd put sine, and then the angle, 35, equals O over H, x over 26. Now x is on top, being divided, so the opposite, the inverse operation is to multiply by 26. Cancel, cancel. Multiply by 26. Make sure you end the parentheses before you multiply by 26. Sine 35, end parentheses times 26. Let's do that. Sine 35, end the parentheses times 26. I get 14.91. And that would be units, whatever the units are. 18. Our theta, our starting angle is 53 degrees, so we're going to label O, H, and A. We don't need O, cross it out. So we have AH, which would be our ca, or cosine. So cosine 53 equals A over H, 45 over, and they are using the letter K. That's our variable. All right. Again, it's two steps of algebra combined into one. The left side and the denominator can switch. So K equals 45 divided by cosine 53. All right, 45 divided by trig cosine 53. And we end up getting 74.77. Units. Alright, last but not least, in this section we got 60 as our theta, so we label O, H, and A. I do not need that O, so AH once again is cosine. Cosine 60 equals A over H, x over 13. To get rid of that denominator, that dividing by 13, the inverse operation is multiplying by 13. Cancel, cancel. Don't forget to end the parentheses before you multiply. So cosine 60 times 13. Cosine 60 and the parentheses times 13 gives us 6.5. Now notice we actually have some units of measure here, so we're going to label our units of measure. 6.5 centimeters. Cool. Alright, these next three, it tells us to use inverse trigonometry. But if it did not tell you that, you would know because you have a missing angle. Inverse trig, missing angle. So let's set this up the same way we always do, and let's get a little Sohcahtoa down here. Bring this down. No. All right, let's try that again. Okay. Yeah. Cool, I'll put this right there. Alright, so we remember Sohcahtoa. Let's start at our theta, which will be this question mark. I'm going to put an X over it. Okay. Let's label O, H, and A. O, H, A. I am not needing this H. There's nothing labeled there. So O and A is going to be TOA. Tan. And remember, after the trig is always the angle, even if we have a missing angle. And in this case, our angle is X. It's missing. Equals O over A, so 21 over 25. Alright, so if we do the inverse of tangent on both sides, we will eliminate the tangent on the left side. So the process is tan can go to the other side if we but put a little inverse sign on it. So X equals tan inverse with the little -1 in the power and the exponent, 21 over 25. So again, to eliminate trig, we do inverse trig. Tan inverse, 21 over 25. Second row of our trig, tan inverse, 21 over 25. And we get 40.03. And since we're looking for missing angles, we got to make sure we put degrees. Same process over here, so my missing angle is X. I label O, H, and A. H is not needed, so OA is TOA. Tan again. So tan X equals O over A. 9 over 29. The tan can travel if we make it inverse. So X equals tan inverse 9 over 29. So trig, tan inverse 9 over 29. 17.24. Degrees. And then last but not least, on this section, missing angle is X. We label O, H, and A. I don't need O, so this is AH. This is cosine X equals A over H. Cosine can travel if it's inverse. So X equals cosine inverse 37 over 40. Back to the calculator. 37 over 40. 22.33. Okay. Hello. Degrees. Okay, so that was trig and inverse trig. Missing side is regular trig. Missing angle is inverse trig. Always label your units of measure. Number 23, we got a flagpole with a 42-foot shadow. It asks us the angle the sun hits the flagpole. So in our picture, we got all we need. Missing angle, 2 sides. We literally just did 3 problems like this. So we know from our missing angle, that's our theta, our X, we label OHA. H is not needed, there's nothing there. This is OA, so hopefully you know that's TOA, tangent. So tan X equals O over A. once again, traveling trig has to be inverse. X equals 10 inverse 42 over 25. So let's type it in. Alright, and we get 59.24. Degrees, because we were looking for the angle. Alright. When you see these should be the easiest thing in the world because you're just typing in the calculator and getting your answer. So let's do that. Cosine 91. Gives us a negative decimal, negative 0.02. We're going to round to the hundredths place. So let's do that. Oh, go away. Sine 24. So trig, sine 24. 0.41. Okay, 1017. .31. And it is in degree mode. Okay, let's simplify the following radicals. The fun part. We got a radical. Remember, simplifying is not decimals, it is factor tree stuff. So right here, we always try to see if 2 works first, but it's odd, so 2 will not work. Let's try 3. And it should work. So let's do 3 times what? We should have 49, I believe. Yeah, and then 49. If you don't know, that is a square number. It has a square root. That is a whole number. 7 times 7. And 7 is prime. 3 is prime. So the other parts of our tree we don't need. So we circle our pairs. And remember, couples go out, loners stay in. 7 square root 3. Cool. Alright, 28. I can already see where people are going to mess up. Did everyone see this? Coefficient 3. Let's circle that to begin with so we don't forget it. And then we're going to break down 60. So it's even. 2 times 30. Well, that's even. So 2 times 15. And then 15, let's try 3. 3 works. 3 times 5. And then cross all this junk out. Alright, do I have any pairs? Yes, I have a pair of 2. And that's it. So please remember, pair of 2, coefficient 3, that was already out, pairs go out, and what's already out, you have to multiply. So that's going to be 6 on the outside. On the inside, I got 2 loners. So remember, if there's more than one of anything, we multiply. 3 times 5 is 15. Okay, most people will forget the 3. Don't be that person. 29, 8 squared root of 3 minus 5 squared root of 3. These are like terms because they have the same square root. So when you add or subtract, you're only operating on the coefficient, the number outside. So 8 minus 5 is 3. And the square root stays the same. The square root does not stay the same when we multiply or divide. That's when we actually operate on the square root. Let's look at 30. So remember, when you're dividing, you can do outside divided by outside, inside divided by inside, if you can. And on 30, I got 2 over no coefficient is an implied 1. So the coefficient would still be 2. And then look at these square roots. Square root of 12 divided by square root of 4. Remember, these square roots can divide, and then 12 over 4 is 3. So we end up with 2 square root 3. All right, 31. Remember, Miss Morero said a square root on the bottom is like cussing, and we don't want to do that. So we want to make sure we rationalize the denominator. So we are going to multiply by the same square root on the bottom and the top. Okay, so on top, 6 times the square root of 3, 6 square root of 3. On the bottom, a square root times the square root is the number under the radical. So you get just 3. No square root sign. And we're almost done, but remember, you want to reduce if you can. And we have a 6 over 3, which equals 2 square root of 3. Okay. Number 32, we got some like terms. If we're adding, we can only add the same square roots. So these square root of 7s, those can be combined. So 8 square root of 7 plus 11 square root of 7, 19 square root of 7. And then our not like term, or unlike term, whatever you want to call it, we're going to bring it down and write it next to it. So plus 4 square root of 5. That is it. We cannot combine anything else because they are not like terms. Everything is as simplified as it can be. So there's that. Last page is geometric mean. So let's remember, we can make this into 2 similar triangles, and we can just make 2 fractions. So this over this equals this over this. So 9 over x equals x over 2. Cross multiply, x squared equals 9 times 2, 18, square root, to get rid of a square, 2 times 9, 3 times 3, pair of 3, x is 3 square root of 2. Similar over here, this over this equals this over this. X over 6 equals 6 over 3. 6 times 6 is 36. X times 3 is 3x. No square, but we do have a coefficient, so we're going to divide. 36 over 3 is 12. Alright, now we'll do these a little bit faster. So whenever x is at altitude inside the triangle, you're going to end up with x squared, and you're going to have to square root. So x squared is 24. Let's do a factor tree. 2 and 12, 2 and 6. 3, 1 pair of 2. So x equals 2 square root, and my 2 loners, 2 and 3, will multiply to make 6. Okay, same idea. Another x altitude, so we're going to have an x squared. 11 times 5 is 55. Now when I try to do this factor tree, I have 2 prime factors and no pairs. If I have no pairs, I cannot reduce the radical. I would leave it as it was, square root of 55. And 2 more real quick. X over 9 equals 9 over 2. We got 18. We got 2x. Divide by 2. X equals 9. And then last one. 15 over 7 equals 7 over x. 7 times 7 is 49. 15 over x, 15 times x is 15x. Divide by 15. That ugly fraction does not reduce. So we'll leave it at that. Alright, and that's your review.